what are machines involved, what are the characteristics of machines, and finally what we have to do with these readings, and that's all. So now problem is that my pen tablet has been because that required a blackboard, and already I use the pen tablet, but that pen tablet is not working presently. So however, I will try here to make you the repetition of this class. So now nobody is coming so far. Josh Singh. Okay, I will allow them and I will take the attendance by the meantime. So let us start. হ্যালো। হ্যাঁ হ্যাঁ, শুনতে পাচ্ছ না? দেখতে পাচ্ছ? আমি কি রিপিট করব এখানে সাউন্ডে? আমি কি বলবো এখান থেকে আবার যদি শোনা না যায়? ওকে। যেহেতু এখন শুনতে পাচ্ছ? হ্যালো। আচ্ছা। So now from this diagram we can see that this is actually basically a cross section of the three-phase synchronous motor, so or generator, whatever it may be. This is we are three-phase windings. The model of the three-phase winding. You know that windings are distributed into the stator, but according to the magnetic axis, each phase winding will have a particular magnetic axis. So that will be hello. So now this three-phase winding has been drawn, and it's a three-phase. Suppose now we can say that. শুনতে পাচ্ছ না কেন বুঝতে পারছি না, দেখতে পাচ্ছি। So there are three-phase voltage basically. One is the phase A like this. One is the phase voltage is like this, and another is there will be the three-phase voltage basically we are having. So this is one, the phase A, and this will be the red one is called the phase B, and similarly there will be a phase C voltage is out of 120 degree apart. So basically the three-phase synchronous generator, or what we get the output we get the three-phase voltage. Now this three-phase voltage will be actually coming out of the generator. Three-phase voltage will be the coming out of the generator. Now suppose this is a generator 1. Now we can say that this is a generator 1. So this generator 1 is capital letter. It is called the ABC, and this generator 1 will have the star connection. If we consider the star connection, then ABC or the terminal voltage will be available from the three-phase winding. And this terminal voltage, if the windings are perfectly balanced, then the equal amplitude and the out of phase will be 120 degree. They are called the balanced voltage. So more or less the balanced voltage will be coming out from the generator. And these three-phase voltage are, if we draw by the Phasor diagram, then you can see that these are the three-phase voltage. One is called the EA, and out of phase EB, and out of phase AC. Now what is the main part is called the synchronization. Synchronization means you have to synchronize this generator with the bus bar. What is the bus bar? Bus bar is called the infinite voltage source, and into the bus bar you know that the voltage and the frequency remain almost constant. You cannot change the bus bar voltage and the frequency. That's why they are called infinite bus bar. So in our laboratory also we are having the infinite bus bar, and that bus bar can be considered another generator, because you know that a grid or bus bar is basically the connection of the multiple generators. They are parallel multiple generators. Suppose the Bandel power station, Kolaghat power station, DVC power station, all the power station are delivering the electrical power, and they are connected to grid, and from that grid we are having these three-phase source in anywhere, for the use. So in our laboratory also we will have this type of three-phase source, and which is coming from the infinite bus bar. So that is called infinite bus bar, but mind it, so that is also basically a synchronous generator. Basically, a property of the synchronous generator will be there. So now synchronization means first part is synchronization. What we have to do, we have to make them parallel connection. That means a capital A and a small a to be connected parallelly, B and B and C and C. So this has to be done. Now, what are the problem for doing that? You can understand what are the problem doing that. First problem is that suppose this is the circuit. So from this circuit, you can see this is a laboratory circuit. Here you can see that the a generator is here. Suppose this is the generator, our generator in laboratory, that is called synchronous generator. So 3 line will be coming out from that, and they will having the voltage. Now we'll drive the generator, because you know a generator should have a driver, that means a prime mover. So you have to drive the generator in a prime mover. You have to drive the generator in a prime mover. So just a minute. Where is this circuit? Now, what is our task basically? Our task is to synchronize to these 2 generator. One generator is here in our laboratory, which will be driven in from the prime mover in our laboratory. Another generator already bus bar. Now, problem is that if you want to synchronize, so this generator will have a particular frequency called the F1, and this generator will have a particular frequency called the F2. Now, when this frequency will not match, then there will be a problem that a current will flow between them, forming a local loop. And as well as if the phase frequency and the amplitude of the voltage of both are not same, then there also will be a current. So according to this, so we cannot do that. And so you have to first confirm that their phase frequency is equal, and as well as their voltage and frequency all are matching. That means equal amplitude and frequency are equal. So that is called the synchronization part. And for this part, you have to do this connection. Okay. So this is the connection. So this is the connection diagram basically. What we are doing here for this connection diagram, first of all, you can see the diagram. In this diagram, you see that the synchronous generator here, that is driven by a motor, and from the connection you see that this is a DC motor. That means current coil is connected through the starter. A 4-point starter is here. You see that this is a 4-point starter for DC machine. And 2 ammeter are connected in armature and the field, so that we can read the current, and the supply is taken from 100 volt DC source. So if we run this DC shunt motor, this is a shunt motor, then we can drive the synchronous generator, as well as we can control the speed. Okay. So if we want to increase the speed, what should we do? Hello, anybody is here with me? কেউ আছো? যদি আমরা এই generator 1 এর frequency বাড়াতে চাই, then what should we do? You have to mind it that there are, for the generator, the prime mover is the delivering. Prime mover can deliver only the active power, whereas a field of the synchronous generator also supplied from a DC source, same DC source with the series resistance and the ammeter. And so this is the field for the synchronous generator. Now you have to remember that the active power or the frequency is decided by the prime mover, and the reactive power is decided by the field coil. So thus you have two control. One is control for the reactive power from the field side, another control is the active power. Now if you want to increase suppose this is the bus bar. Now you have to parallel the generator with the bus bar, infinite bus. So now what you have to do, if the frequency of the generator is to be increased, then this motor should have the higher speed. So you have to increase the speed. So how to increase the speed of the shunt generator? Hello. So what is the method for this shunt generator to increase the speed? You have to change the field current, okay? So you know you have to the speed can be changed from the armature side, but here the armature side cannot have any scope here because voltage is fixed. You cannot change the speed from that side. You have to change the speed from the field. If you decrease the field current by this resistance, then speed will increase, and vice versa. Similarly, so now what is the connection? Now you have to see that this generator is connected through ammeter to the bus bar and through wattmeter. 2 wattmeter method we have to use. 1 wattmeter is called this is the 1 wattmeter, and this 1 wattmeter is connected as a current coil is in series and potential coil across them. Similarly, another wattmeter is there, current coil in series and the potential coil across. And you know that 3-phase power, balance power especially, can be measured by the 2 wattmeter method. And before connecting, this is the main connector which will parallel this bus bar and the generator. But before connecting, you have to check whether this generator is having the same phase sequence with this, whether this generator having the voltage level of this with this bus bar, whether the frequency is the same. So now here a connection meter are connected, a frequency meter is connected, a voltmeter is connected like that there is a changeover switch. Sometimes you can measure the frequency of this generator, sometimes you can measure the generator of this bus bar frequency. So thus by difference of this frequency you can vary the speed of the shunt motor and you can go for approximately equal to the frequency of the bus bar. And similarly, voltage also, you can measure the voltage here. Suppose it is the 110, but however, generator is not reaching the up to 110, it is reaching up to 100. So you can increase this speed by field current. By field current, you can increase the voltage. So if you increase the field current, voltage will increase, thus it will be at par. But these two things can be done by this frequency meter and voltmeter. But phase sequence is very difficult by the voltmeter and the frequency meter. So what will be now we will be doing for the phase sequence? Somebody is trying to join, okay? So what I do? It will be very problematic for me. Okay.
Sir, you can use the Google Meet whiteboard.
Whiteboard? ওটা আমি whiteboard আমি বুঝেছি ওই হোয়াইট বোর্ড ইউজ করতে গিয়ে আমার পেন ট্যাবলেট ডিসেবল করে দিয়েছে আগেরবার গুগল মিটে। এটা আমি আগেরবার পেন ট্যাবলেট থেকে নিয়েছিলাম, কিন্তু হোয়াইট বোর্ডের সমস্যা হচ্ছে হোয়াইট বোর্ডে লেখা ঠিক করে যায় না, মাউস দিয়ে লিখতে হয়, দেয়ার ইজ নো পেন। বাট ইন মাই পেন ট্যাবলেট আই হ্যাভ পেন, বাট মেইন প্রবলেম ইজ দ্যাট ওয়ান্স আই হ্যাভ ইউজ দি হোয়াইট বোর্ড, আমাদের সেকেন্ড ইয়ারে কেউ এটা সাজেস্ট করে, তারপর থেকে আমাকে পেন ট্যাবলেট ইউজই করতে দিচ্ছে না গুগল। তো আমি সেটাকে ডিসেবল করতে এখনো পারিনি, পেন ট্যাবলেটও ইউজ করতে পারিনি, যার ফলে আমার এই অবস্থা। আমি ঠিক করে কিছু এখন করতেই পারছি না, এখন কি করা যাবে, এখন এটা দিয়ে চালাতে হবে আমাকে। তো নাও ইফ ইউ হ্যাভ এনি ডাউট ইউ ক্যান আস্ক মি। হ্যাঁ, এই হচ্ছে প্রবলেম আমার। আর এবার ভিডিওটাও কিছু আসছে না, যাকে ভিডিও দরকার নেই, ভিডিওতে সেভাবে ভালো কিছু হয় না, বাট আই উইল এক্সপ্লেইন অল দিস থিংস। এখন যেটা করতে হবে ফর দি ডিটারমিনেশন অফ দি ফেজ সিকোয়েন্স, হোয়াট উই হ্যাভ টু ডু ফর দি আবার কে এসছে, পরপর এসেই যাচ্ছে কেন এরকম? লেট দেম জয়েন। Lamp 1, lamp 2, lamp 3. Now, if you minutely observe, then you see that between small a and capital A, that means same line, a lamp is connected. But for the other phase, you can say that for the B phase, here the line is connected to the C phase. A lamp is connected. Similarly, for C phase bus bar, the lamp is connected to the B phase. That means there is a cross connection. Okay. So there is a cross connection. Now, If this frequency and voltage are matching, so they are exactly equal. But if the phase sequence is not equal, that means they are the one condition, maybe there are same phase sequence both. Another condition, maybe they are the opposite phase sequence. Now first we consider that there are same phase sequence. So however voltage and frequency both are same, and if we connect the lamp for the same phase, suppose A phase and A phase, then what will be the condition for this lamp? Whether it is glow or it will be dark.
Sir, can you please repeat the question once?
Question is that if we connect in a three-phase, two three-phase are there, okay, one generator, one bus bar. Now they are same kind, but if the phase sequence are same, then A, suppose this capital A, this is small a, same phase. So if we connect a lamp, when the voltage and frequency of both are same, then this lamp will glow or
Glow,
not?
sir. Glow, sir.
Lamp will be bright, dark.
Dark side.
Dark. And if we connect the cross connection, that means from this C we have to connect generator B, then what will happen? This lamp will be bright, very bright, because there will be, you know that in a phase sequence when you connect, basically we are connecting with the B and C. A lamp is connected between the lines, basically B and C, that means there are two lines. Similarly, here also the lamp, three number lamp also will be glowing. So if they are both frequency and voltage match, then this one will be dark and this will be the bright. So this is method is called the one dark two bright lamp method. But actually frequency meter is not a very correct device. So it will, however, you can have a slight difference of frequency will be there. So you will see that there is a this dark and bright will be varying sequentially with the difference frequency. Suppose, so it is a 50 Hz, but here generator is 49 Hz. So you cannot have the measurement in frequency meter like that, because frequency meter may have some error. So this lamp will then glow with this one frequency. Okay, in 1 second you will see that it will be glowing and it will be bright sequentially. Okay, so thus this is a very opportunistic moment for your synchronization. Now if you gradually slightly increase the frequency by this shunt motor, increasing the speed, then further this sequential glowing and dark period will be diminished, and gradually you will see there is a very slow rise of the dark and the bright. So thus when it is approximately static, they are not moving at all. So they are dark and bright, both are almost static. In that case, when this dark and the two lamp is bright, then you can on this switch. Okay, this is called synchronization. Got my point? What is synchronization?
Yes, sir.
Okay. So does this synchronization, because you can observe into the laboratory, okay, but here I cannot make you the this glowing of that, but I have described that this is a process. So this process. Now during this synchronization, so it is synchronized. Now you have to say what is the condition of this generator, whether it is generator, whether it is motor. Now it is obviously a generator, because before connection here it was a generator, because its prime movers were driven by the motor. So after also we can assume that it will be behaving a generator. Now we can say that a synchronous generator is connected to the infinite bus bar. Now the next task is, what is the next task? Next task is, now we have to formulate the load. So you have to now push the load from the generator to bus bar. So what is the process of pushing a power from generator to bus bar? Can anybody have this idea? So here you can see into the circuit which will control the power flow from the generator to the bus bar. Active power. Suppose the wattmeter is reading the active power. Now you want to push the power from the generator to the infinite bus bar. An infinite bus bar having some loads. We cannot see that, but that will be supplied finally from the generator. So you can say now when this can happen, already we have told that the synchronous generator condition only the prime mover can deliver the active power. So when the frequency of the generator is to be increasing tendency with respect of the bus bar, then only the generator can drive power to the bus bar. So what we should do? We should do the decrease of the field current, okay, of this shunt generator, so that it can push the power to this. Now, when it is done, then you see that these two wattmeter reading will be different, because we don't know at what position we are doing it. What position? That means a synchronous generator deliver power in a particular power factor. Okay, so this power factor may be lagging, maybe unity, maybe leading, whatever it may be. So that power factor is decided by the field current. So we don't know what is the power factor. So now the basis of this is that you have to start from the maximum power factor. That means from unity power factor. The first task is for this you have to make the unity power factor again. Another specification is that you have to make the half of the load, okay, so that it can deliver half of the load, not full load, because that will be very difficult situation for controlling, because we have not a modernized controlling system. Here is the whole conventional controlling system. So from this controlling system we cannot do the full load, because you know that in a synchronous machine there is a main problem is the stability. So if the machine lose the stability, then again you have to go back for the synchronization. Again you have to do the lots of things. Again you have to repeat this process. So that's why in a safe side it is better to start with the half load. So that's why it is done. So how to make the half load with the unity power factor? You know that in a three-phase system, if we want to measure the three-phase power, then summation of these two wattmeter reading will give you the total power, active power. But if we see that the both wattmeter is reading same amount of power, then we can say that power factor is 1. Got my point? You have to remember three-phase wattmeter method. When the power factor is giving one power, try to remember. It will be only then when the both wattmeter will read the same. So both wattmeter will read the same, and the by this reading of this both wattmeter and some watt is kilowatt will be displaying, and by the knowing the rating of the generator, what is the actual kilowatt it should deliver for rated condition. So by the summation of these two wattmeter, we can have the starting point of this the experiment. So now first part is we have to deliver power to the bus bar. So that means synchronous generator will deliver power. Now we can shift to we can shift to laboratory sheet. Okay, that will be better for me, because it is not working. So I can shift to the laboratory sheet. Where is the lab? Where is the class? Design routine. Okay, by the meantime, it's not coming.
Sir, we can send you in mail. That's why you can open it. We can send you in mail the laboratory sheet.
You can send just now?
Yes, sir. One second, sir.
Okay, just a minute. Send me. I am here.
One second, sir. Sir, can you please tell your mail ID, sir? The initial ID.
Oh, same mail?
Sir,
Jadavpur University.
can you please the initial? I mean the first name before the @ first.
Jadavpur
Sir, you can
University.
click on the icon of M. There is written there.
Okay. So,
Sir, madhav.roy@jadavpur.university.in.
just I am seeing here. Can you see here the upper one, Madhav
Yes, sir.
Roy?
@jadavpur.university.in.
Okay.
Yes, sir. Sending. Sir, thanks, sir.
Okay.
The mail is delivered.
You have got it. Okay. Now we can read it. Connect the alternator is coupled with DC shunt motor with the synchronizing board. Top lamp is the lamp which is connected across the same phase of the bus bar and the incoming machine. That means infinite bus bar, and other two lamp, that means generator. The other two lamp are connected across two different phases of bus bar and machine. Connect the DC motor through the starter and start the motor. Make the voltage and frequency to that of the bus bar. Switch on to the incoming machine to the bus by observing both the following method. One lamp becomes dark, other two becomes equally bright, or LED indicator of synchroscope becomes. So there is a synchroscope also. You can do the LED, but that is not a learning here. Okay, for the learning you can do the three lamp method. Okay, that will be better. Okay. So that has been done. Already we have done. Partial current of DC. What is DC? It will be DC. DC means and synchronous machine. Okay. DC motor. Actually, it will be a mistake here. Vary the field current of the DC motor and synchronous machine so that this synchronous machine delivers 1/2 of load at unity power factor. Okay, I have already told. And record values of this DC and synchronous machine field current vary the field current of the synchronous machine above and below this value, and the record the DC machine armature current, AC line current, real reactive power as a function of the synchronous machine field current, limit the AC current to 120% of the rating of the machine, maintain the armature current DC machine constant. Okay. So this is another part. Third part is starting with the synchronous machine delivering half load. This is our run basically. So starting third run we are starting now. Starting with the synchronous machine delivering half load at unity power factor. Okay, I have already told that for the unity power factor, there are two control. One control is called the power. Amount of the power should be controlled by the shunt motor. That means from the prime mover. And another control power factor. Power factor means that will be controlled by the field of the synchronous generator. So by both doing that, you can control the half load and the unity power factor, and that will be reflected into the 2-watt meter connected to this 3-phase machine. So 2-watt meter, when the 2-watt meter will show the equal reading, positive reading, then the power factor will be 1. Okay, so then the power factor will be 1. Okay. So vary the field current of the DC machine above and below its original value, and read the record quantities listed in the run 2, and keep the alternator field current constant. Do not overload of the any machine. Number 4. So that is actually 1, 2, 3. They have described as a what we can say as a ITI student. Okay, as you're not engineer. So if you advise from the point of engineer and from the knowledge, then so much instruction is not required. So they are just instructing you what to do mechanically. But actually we have done all of this from the understanding point of view, what is we are doing basically with the synchronous generator. Now actual reading is starting from the take reading to obtain no load V curve armature current versus field current of the synchronous machine. Limit the armature current 125%. So from here you can see that. So we have taken a no load V curve. That is the no load V curve. Okay. Can you see the V curve now? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. For this, what we have to do basically? For this, what we have to do? One axis is called the armature current, that is the synchronous generator armature. Another axis is called the field current, that is also synchronous machine field current. What we have starting point is here. That means this armature current is related with the loading. That means half load. So this armature will decide how much load is there. And this point will decide the 2-watt meter as equal reading. Okay. So that is called the minimum power delivered from the generator, and this minimum power is basically point of unity power factor. Now for synchronous generator, you know that the active power cannot be changed unless we change the prime mover. Okay, or we cannot change the active power from the field side. So if we keep the active power fixed, then what we should do? We don't touch the prime mover. Okay, that means we will not touch the shunt motor connected, DC motor connected to the prime mover. So if we don't touch the shunt motor, whatever it is at this position, now if we vary the field current of the synchronous generator, then this curve will be achieved. So now what we have to do? First reading we have to take here for unity power factor. Then what we will do? Then you see that we will reduce the field current from this end. So gradually we are decreasing the field current. So you see that armature current is increasing, because you know that now the armature current is composed of active power component as well as reactive power component. So that will increase. So that is the theory. In theory you have understood this. However, this link will be shared to you. Okay, this video file I will share to you. If you can play, then you can understand everything. But now it is not playing, so that is my problem. So now, can you say if we decrease the field current for synchronous generator from the unity power factor, so the armature current will increase. So we have to take some readings at this end. Okay, and this is called the physical reading we have to take in the laboratory. So that means what we have to measure here for this left half portion, we have to measure the ammeter reading. Suppose we have to, what we have to measure here, we have to measure these readings. Okay, for this we have to measure for the left half portion. Left half portion is now this machine motor is untouched, and this field current will be varied by this varying the resistance. And so if we decrease the field current, then current will increase, and that means this 2 wattmeter will read different values, and gradually by the 2 wattmeter we can measure the reactive power also, and the ammeter current also will increase, because we have seen that the reactive power component of the current will be coming into picture for the synchronous generator. And this is the run. Okay, this run you have to take, and how much will go for the ammeter current? So that is restricted to 125% of the rated current. So you cannot increase beyond that. So then we will stop here. Okay. Now we will stop up to this point. Suppose this is the 125%. Now we have to come back again unity power factor gradually, not taking reading. Okay, for initial position, this position will come. Again we have to increase the field current. Okay, then what we have to do? We have to do the increase this synchronous machine field current gradually, so that we can take the power and ammeter reading. And so that has to be done by this right hand side. So thus these readings taken increasing the field current, again 125% will stop here. Now tell me which side power factor is leading, which side power, and if we plot, then we'll have a V curve like this. So which side power factor is leading, which side power factor is lagging?
Sir, right side is the lagging and the left side is the leading one.
Yeah. So that can be also supplemented by this Phasor diagram. You say that this is a Phasor diagram we have drawn. So here you see that this is a Phasor diagram. This is a Phasor diagram. You can see the Phasor diagram is for the terminal voltage. First you see that this is the terminal voltage. Okay. So now this is the terminal voltage VA. Then the per phase basis. Then the resistance drop is here, and then the reactance drop, synchronous reactance. You know that in a synchronous machine there are reactances different from all other machine, because in synchronous machine only the reactance is called synchronous reactance. That is involved the another concept. So synchronous reactance is the another concept which is involved. That synchronous reactance, you know, understand, that is related with the armature reaction. You have to remember. So there are different type of armature reaction. So that armature reaction is incorporated into a form of the reactance. So that is not available in any other machine. This is only available in the synchronous machine. So this synchronous reactance. So now for the unity power factor, what does it mean? It means that the VA and the IA will be on the same line. That means same phase. Then if we draw, then we will see that this will be the E. That means E for the that means generated voltage for the synchronous generator. So this is the Phasor diagram. From here we can see that actually the field current is, as the frequency is constant, so the EMF induced is proportional with the frequency as well as the field current. So this length is the induced EMF as the frequency is fixed, because it is tied up with the infinite bus bar which cannot vary. So that's why frequency must be fixed. And so in that case, this length will actually induced EMF will be decided by the excitation or the field current. So you see that for the unity power factor, the field current is minimum. Now for the left hand side, from the left hand side, you see that if you draw the leading power factor current, then this will be the drawing. You see that this will be the drawing. That means this will be the terminal voltage and this will be the armature current. If it is a leading power factor, then you can draw that this is the resistance drop into the Phasor diagram, and this is the reactance drop, and thus you can see that here induced voltage is reduced less than the active, that means for unity power factor. So length is less, that means the field current is less. So when we reduce the field current, so it automatically goes to the leading power factor region, and vice versa. If we do suppose if we do the field current more, then for the same active power, you know that there will be a horizontal line that is called constant power application. You have to remember what is the constant power application. That means the power line will not shift unless we change the the prime mover. So you can draw a vertical horizontal line here in parallel with the VA, and these tips of these will lie on that, whatever the field current we apply. So then for the overexcitation, you will see that the field current will go to the further distance. So this will be the induced EMF, and thus you will see that this IA will be lagging to the applied voltage. So it will go down. So this is the explanation of the V curves for the synchronous generator. Got my point? Hello?
Yes, sir.
Okay. Okay. So this is the first reading we have taken. So now we have to go for the next result. Okay. The next result is take the readings to obtain the no load V curve. We have taken number 4. Now we have to run number 5. Synchronous machine. Then take reading or to obtain the no load V curve, armature current, field current of the synchronous machine. No load. Now number 4 you have to take. Okay. Number 4. Number 4 is called the no load V curve. So now we go for the V curve here. What will be now? What will be the no load V curve? Here is a load. So what should we do if we want to make the synchronous machine as a no load V curve? Then what should we do? Can you have the idea from this?
Yes, sir.
So that means no load means IA will be this amount of will be 0, or you can bring back this curve to the horizontal axis. Okay, got my point?
Yes, sir.
Okay, you have to bring down this curve to the horizontal axis, keeping as it is. Okay, so now for this, what you have to do? You have to reduce the active power deliver, and there the active power deliver can be reduced. How you can do that? Okay, now you go for the circuit. Here, if you now reduce the speed here for the shunt generator by the changing the field current, then you will say that this power rating is reducing. Okay, power rating is reducing. Now further reducing the speed of the shunt motor, then again this amount of power will be reducing. Now at one point of time we will see that one wattmeter is positive, but another wattmeter is giving negative reading. That means, so in that case, that means it is going to be 0 power. That means when this one wattmeter will be positive and equal another wattmeter will give the negative reading, then what will be the power output? Okay, that power output is 0. So that is called no load condition, and we have to achieve that no load condition from this controlling the shunt motor. So gradually we can do that, and actually negative reading in a wattmeter. How to take the negative reading in a wattmeter? The negative reading can be taken because the pointer will go on the reverse side, but that can be only taken when we alter the current coil terminals, and again we take the reading. Then it will read positive value, but actually it is negative value. So one wattmeter will be altered by the changing the current coil terminal. So that's why current current terminal alternation facility available in this wattmeter. Okay, these are not, current coils are not fixed. You can alter on the line system because you cannot off this system because it is synchronized. Once it is off, again you have to repeat all of this synchronization process. So you cannot do that. So that is in the facility. So by doing this, seeing the wattmeters and the changing the speed of the shunt motor, we can now see that the reading has become the 0, and these two reading must be equal. So that is called no load condition. At that condition, and this meter, the ammeter of this generator, shunt motor will reduce reading, because when it is delivering the power, the half load, then this ammeter shunt motor reading, ammeter reading will be high, because any power delivering system of the shunt motor or any kind of DC motor is related with the armature current. Mind it, it is not related with the field current. So armature current of a DC motor will decide the power. So that's why when you are reducing the power from half load to 0, so this ammeter reading will be reduced. So this is the although it is running as a motor, and so it is a floating condition. Now generator is not delivering any power, so it is in floating condition. So that condition is called the no load condition. So how four no load condition is achieved? Now got my point? Hello.
Yes, sir. Sir, we will
Ah.
get negative reading of wattmeter only in no load condition, or can we get in light load condition also in negative reading of wattmeter?
Like load condition also we can get, because the if the power factor, suppose this is the reading, so if this load is suppose the reactive load, okay, so very much reactive load, okay, so in case of reactive load, one ammeter can get the positive reading, another reactive load means what? That is means low power factor, okay. So you know that this wattmeter, when the low power factor, what does it mean? You have to remember the 2 wattmeter method, where you can see that if the angle goes beyond the 30° between the voltage and current, then what will be the condition for the wattmeter? Can you remember those things for the wattmeter?
Yes, sir.
By 2 wattmeter method, two-line system. Okay, when the angle between voltage and current going below the 30°, then what will be the reading?
Yes, sir.
That reading will be negative. What my point? Okay, so that means the power factor is involved. When you're reducing the power factor, okay, then that means under excitation, very much under excitation, very much over excitation. There, then only the 1 wattmeter will go the negative reading. Got my point? Hello.
Yes, yes, sir.
Okay. So that is the way. So that way you can see that. Now we can see that. So by doing this, again we can take the reading of the vehicle. Okay, this is the we are asking. Oh. This cow has appeared. Okay, this is the type. Okay, I will show the link. Okay. So this is the actually we are want. So no load means this is the curve. Got my point? Hello.
Sir.
Yes, sir. This is the condition of no load. Again, for this condition, as it is a no load, you don't touch the shunt motor, because active power is now at no load condition. Now for this no load condition, again you reduce the field current, then you will get this reading. Again you reduce the field current, then okay. Oh. Why it is moving? Okay. Now for this will be down position, and for this it will be down position. It will be no load curve. Okay. Now this is, now tell me whether the it is a motor or generator till this at no load condition. Hello.
Sir, at no load condition, it is not delivering any power, so it is.
What does it mean? This is very critical question, because this is involved with the concept of the coupled shunt motor, concept of the synchronous machine power delivering system. So now when this curve touches to zero position, this minimum point, then you have to identify whether this synchronous machine, whether it is motor, whether it is generator, what it is.
Motor.
Huh?
Sir, actually, no load is connected in the generating side, so I think it's motor only.
So now problem is that that will be decided by the this side. Okay, I have already told that this motor will decide whether it is generator or motor. Okay, so now if this motor takes power, okay, from the DC side, so that will this motor will have some shaft output. Okay, got my point?
Yes, sir.
That shaft output is a law for conservation of the energy. If it is connected to the generator, okay. So now if this both active power is becoming zero, still it is a generator, okay, because this motor is driving the generator, okay.
Yes, sir.
Okay, but if it is a motor, synchronous motor, then power flow should be reversed. That means any condition, this motor should not drive this generator. Got my point?
Yes, sir.
Sir,
So
in
now,
motor condition, sir, in motor condition,
follow.
the generator, in motor condition, the synchronous motor will consume the reactive power. When that's how you can
না
explain that.
সেটা 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 তো অন্য প্রশ্ন, সেটা তো রিঅ্যাক্টিভ পাওয়ারের প্রশ্নটা তো আমি আনছি পরে। আগে যেটা বলতে চাইছি যে যখন এই জেনারেটরের পাওয়ারটা জিরো আছে, মানে 2 ওয়াট মিটার ইজ ইকুয়াল রিডিং, that means this generator is not giving any or taking any power from the source. So floating condition. Now what is this? It is a generator or it is a motor? How we can decide? বুঝলে?
Yes, sir. It's coupled with the DC shunt motor. That's how you can say the generator.
Okay, okay. It is a coupled with the DC shunt motor. Now, if it is a motor, okay, then what is the condition? That DC shunt motor should not take any power from the source. Right?
Yes.
Okay. So if it should have a motor, then this ammeter reading of the DC shunt motor should be zero. You know that. Unless the ammeter reading of the DC shunt motor is zero, then you cannot say that this synchronous side is a generator or motor. Only then you can confirm that it is a motor, because now this motor is not taking any power from the source. Okay. Now,
Yes, sir.
if the synchro runs, then it is runs from the AC side. Got my point? Hello.
Yes, sir. Yes, sir.
Okay. So at that condition, we can say that. So if it is a no load floating condition, but still, if this motor reads some amount of armature current, we cannot say that it is a generator or motor. We can say it is a synchronous machine. Up to that, it is a motor. Then it is a generator. Okay. A motor and generator set is here. So if one is motor in a prime mover, then another must have the generator. Okay. So that is called the, now curve number 4 is called the V curve of the synchronous generator at no load. Okay. V curve of the synchronous generator at no load. Okay. This is the V curve generator of the synchronous machine. Or you can say it is a synchronous machine, because it is very difficult to identify it is a motor or generator. Now we go for the run number 5. The run number 5, the DC machine as a generator take V curve of synchronous machine, keeping the DC output constant, half rated load. Current AC side should not go beyond at the times rated value. এই উল্টো পাল্টা ইনস্ট্রাকশন শিট আছে, কার যে এক্সপেরিমেন্ট হচ্ছে সেটাই বুঝতে পারছো রান 5 করে?
No, sir. Sir, I think now the generator is working as motor.
They should write that only. Now they have instructing from the DC machine side. Okay, this is a very wrong approach, because already I know that synchronous machine on one status. Now what is we have to do? We have to do synchronous motor, synchronous machine now should be converted as a synchronous motor. Got my point?
Yes, sir.
So how can we do that? If we go for the circuit, so if we go for the circuit, we see that when this generator will be motor, only when if we can load this DC shunt machine as a generator, got my point?
Yes, sir.
Then power flow will be reversed. That means the shaft now will drive the power to the this generator. Okay. So now this will be as a motor. Okay. So when it is a motor and this is a generator, that means shunt motor now acts as a generator, and the synchronous machine acts as a motor. That is only way when this power taking out from the shunt machine. So shunt motor or shunt generator. So how can you identify that whether it is motor or not generator? Now earlier when it was a motor, then ammeter, this is a DC ammeter, you will see that it will pointer will move to some direction. But when this motor again will be the generator, what will be the ammeter pointer?
It will not move.
It will not move. Okay. So that's why this ammeter is a very special kind of DC ammeter. So it is a bidirectional. Okay. So it will have some value to 0, again some positive value. Got my point? What is the pointer?
Yes, sir.
Okay, pointer can move both sides. So when this ammeter will read the direction of the current in opposite side, then we can assume that this is acting as a generator and it is acting as a synchronous motor. And you will see that the power flow of this wattmeter will be both reverse. That means already we have one wattmeter is giving the reverse. That means current coil we have altered. Again, when it is becoming a motor, again the power flow will be reversed. Then the another wattmeter current coil will also be reversed. So now the wattmeter reading now will be in opposite values. That means for the generator it was plus. Now the motor it will be minus. So we can achieve it. We can achieve it. So from this, again we can go from the 2 wattmeter method for this now motor acting as a generator, and this can be achieved by varying the field current. Okay, if we change the field current, then this also acts as a generator. And now the this synchronous generator now acts as a motor, and again we will go for the unity power factor. I mean, 2 wattmeter will be reading equal, and it will be half load. Already I have told you, and so the generator will deliver. This generator will deliver that amount of reading only for the half load of the motor. So this is called the synchronous motor operation. So now run 5. So that has been told here. Run the DC machine as a generator. So they have told indirectly what you should do. Take V curve of synchronous machine, keeping the DC output constant at half rated value. The current on AC side should not go beyond, again, 125 plus the value. Okay, and again the reading you have to take the V curve like this. Again you have to take. So again the reading will come. So this will form a half load and the V curve. Now tell me which side is lagging and which side is leading.
So right side will be leading and left side will be lagging.
So over excitation. Right side will be over excitation.
Yes.
So and the left side will be under excitation for the synchronous motor, and the power factor of this will be like this. So we can say that what will be the power factor. So this is, you can say. Can you view this? Hello.
Yes, sir.
Okay. This is the phasor diagram now. Okay. If we neglect the resistance for the temporarily, then for the DC synchronous motor, this will be the terminal voltage V. Okay. Now for this point, over excitation, you see that for this is the point. What will be the phasor diagram? For this point, you will see that the induced EMF will be EA, and that will be coming down because here the IA armature current will lead to the terminal voltage. Okay, lead to the terminal voltage. So now if we extend, then it will be the J excess. This drop is called the J excess, which will touch the current line with 90 degree. This is the phasor diagram concept. Those who know the phasor diagram drawing for the synchronous motor, they can understand this. Okay, got my point?
Yes, sir.
So this is the point of the over excitation. So that you can verify that this is a leading power factor load. And you see that here the EA is the length which is dependent on the field current. So here the field current is much because length of the EA will be much. If we go over the further excitation, further increase of the field current, then current will increase. We can see that it will be because it is constant for the EA sin delta. This is called the delta angle, and EA sin delta will be constant. You know that for constant power operation. Got my point? Hey, have you studied constant power operation?
Yes, sir. Yes, sir.
Okay. In that case, the EA sin delta remain constant. Okay. This is called the torque angle or the power angle between the voltage and the induced EMF. So sin delta, EA sin delta means this line, vertical line will be constant. So if we increase the field current, so EA will be changing. So it will come here, but on the horizontal line, the EA sin delta constant. So from here also you see that as we increase the field current, EA is increasing, and thereby the power factor is going to more leading. Okay, so that will be the more leading. So it will further align, it will go here, and so it will align here. So this is the justification for the leading power factor load. What my point? So that is established. And similar thing will happen left hand side if it is under excitation. Under excitation means this length will be very less. We can say that in that case the length will be less. Suppose this is the half of the length of the EA. Then JXS will be along this direction, and you can see that what will be the direction of the EA. So EA will come down here. Okay, you will come down because it will be the 90-degree always. So that's the lagging power factor will appear. So this is called synchronous condenser basically. Now if we do a no load condition, that means it will touch here. So if we operate this, that is called the synchronous condenser, and that is used in the industry for the power factor correction system. So that is also another very much application of the synchronous motor. So this is the number 5th reading. Now number 6th reading. So in the 6th reading, run 5. Reduce the, again they have instructed like a, what should we do? Clearly they have not told. Okay, run 5, reduce the DC load to 0. DC load to 0. Hey, ki bolche go?
Sir, DC generator at no load, I think. Sir, earlier we were operating at half load, but now we should run it at no load. I think
so that means DC load to 0, na DC machine current to 0.
Yes, sir, right.
So again reduce the DC machine current to 0. Okay, so that means we are going for no load, and then switch off the synchronous motor field current and record all the readings. Increase the load on DC side slowly with the stroboscopy arrangement. Note at what load the machine starts slipping. So now we go for the diagram here. So what is the run 6? Run 6 is that they are telling that first you become 0. That means this ammeter, DC shunt motor ammeter will be 0 reading. Okay, and you have to switch off the field current of the synchronous machine. আচ্ছা আমাকে বলো তো যে আমি যদি এর প্রাইম মুভারের আউটপুটটাকে 0 করে দিই এবং এই সিনক্রোনাস মেশিনের ফিল্ড কারেন্টটাকেও 0 করে দিই, তাহলে এই যে সিনক্রোনাস মোটর একটু আগে ছিল সেটা কি ঘুরবে কি ঘুরবে না?
Sir, with 0 excitation, how? Sir, RMF will not form, sir, with 0 excitation.
So whether it will run or not,
No,
revolve or not.
So it can take armature current. It can take armature current from the bus.
আর্মেচার কারেন্ট আছে, শুধু ফিল্ডে কিছু নেই, ফিল্ড 0, ডিসি ফিল্ড তো ইনসাইড থাকে, সেটা 0, ফিল্ড কারণ সুইচ অফ করা হয়ে গেছে, এবং এই প্রাইম মুভারও 0 আছে, প্রাইম মুভারও কোনো সাপ্লাই নেই।
Sir, but it will try to retain due to the inertia. It will try to move, or because of the locking between the poles.
No, it is electrically connected. What is the inertia? Inertia to mechanically কিছুক্ষণ চলবে, তারপরে
it has residual magnetism in their
yes, sir.
in the field region.
মানে তুমি বলছো যে ফিল্ডের রেসিডুয়াল ম্যাগনেটিজমের জন্য ওটা পার্মানেন্ট ম্যাগনেট হিসাবে ঘুরবে,
Sir,
পার্মানেন্ট ম্যাগনেট ডিসি মোটর
For sometimes.
মেন পোল হলে রান করবে।
yes.
Huh?
Sir, पहले तो
পোল
sir.
মোটর হলে রিলাক্টেন্স পাওয়ার দিয়ে রান করবে।
Yes. So now if this motor is this synchronous machine, you have to now stress on the construction of the synchronous machine. You don't know what is the type of the synchronous machine. If the synchronous machine are two type, one is called cylindrical rotor, another is called the salient rotor type. Okay. If the synchronous machine is not cylindrical, where the cylindrical rotor means the reluctance, DQ reluctance, that means D-axis and Q-axis reluctance is equal for the cylindrical rotor machine. But in case of the salient pole machine, you will have the difference of the reluctance. So the direct axis reluctance is very low, whereas a quadrature axis or Q-axis reluctance is very high. So now due to this difference in reluctance, it will run as a reluctance motor. Got my point?
Yes, sir.
Yes, sir.
So in spite of the field circuit is off, and the field circuit means this field is very soft field, because in a DC machine you don't have any permanent magnetism, because when you are giving the field excitation, because you don't need it, because it is not desirable. So very soft type of magnet is used here. So we don't assume that any permanent magnet will act when the field circuit is withdrawn. So then, however, this motor is running because it is neither having a connection from the rotor side, any mechanical drive. So it is running. That means it is running now as a reluctance motor. Got my point?
Yes, sir.
Yes, sir.
Okay. Now, problem of the reluctance motor that we are not having any power from the field side. Okay. So only it is power from the difference of reluctance, salient pole, due to the salient pole. Now, basically, this type of motor works in a very low power factor. Okay, where the power factor is becoming very low, and that's why its output power for this type of motor is becoming very less. Okay, so that's why again we try to, if it is a if we try to loading this reluctance motor, you can do that. Again, we are this shunt motor can be run as a generator. Okay, and this shunt motor can be run as a generator, and you can see that at certain amount of generator, very reduced amount of generator action, this 2 watt meter reading as well as this ammeter reading will be very high. So this is the final reading we have to take. And another point is that at certain amount of power, if we further increase the power, when we are further trying to taking out of the power from this three-phase system from the DC generator, then what will happen? This synchronous reluctance motor will be out of step. Do you know what is out of step?
No, sir.
What does it? You don't know out of step. Out of step means you know that actually what happens when we already I have told that the power angle or the sine delta. So if we increase the power from any synchronous generator motor, then delta must change. Okay, and delta is basically, if you go inside, you'll see that delta is the angle between the poles of the rotor poles and as the three-phase stator poles. Okay, because these poles are matched, equal number of poles are there. You cannot see because the construction of the stator of the synchronous machine is same to the construction of the induction machine stator. That means when three-phase stator of the synchronous machine carries current, then there will be a rotating magnetic field, and that rotating magnetic field will be the number of poles, and that number of poles will be equal with the number of rotor poles. Now, when because you know that when we increase the loading in a synchronous machine, whether it may be generator, whether it may be the motor, then the alignment or axis of these two poles, from the stator poles and from the rotor pole, and there will be some difference between the axes, and physically you can see, visualize that physical mechanical degree of this alignment is measured by the delta. This is called delta, and that is reflected into the voltage phasor. We have already shown that the angle between the terminal voltage V and the induced EMF E is called the delta. Similar thing happen into the rotor and stator poles. Now, when this angle increases, that means you are delivering more power. Okay. Now, gradually this angle will increase and increase, and one time will come that the north pole and south pole will not be tied up. Rather,
Yes.
the north pole of the rotor will leave the south pole of the stator, and that will cause the condition of the slipping. Know that? What is the slipping?
Yes, sir.
Okay, that thing will happen if you want to further increase this loading from the generator. Then you will have a slipping action. But actually, that can be observed into the laboratory, because there is a disc connected into the shaft, and this disc, when we add synchronization, you will see that disc having the multiple shaded portion, one black, white, like that, depending on the number of poles. Now, when it is synchronized, basically it is rotating with the rotor, that disc, but you will observe that disc is static. You cannot visualize that it is a rotating. This is a beauty of this disc. And now, when it will be out of step, then this disc will be slipping. That is called slipping condition. So here also something written here, is it? So what load the machine starts slipping? Okay, this is called machine starts slipping. Okay, this is called the slippage of this. So this is the final. Now report for run 2 and run 3. You have to basically do all the V cups. Got my point? One V cup for the synchronous machine started. One V cup for the synchronous generator power delivered. Another V cup when the synchronous machine no load, 0. Another V cup when the synchronous motor is delivering power with some load. So this type of V card you have to draw. I will send you the data. Okay, তোমাদের ডাটাটা আমার কাছে এখনই নেই, আমি এখনই এখানে আমার ল্যাবরেটরি রিপোর্ট আছে, সেখান থেকে স্ক্যান করে তোমাদের এই ইমেল অ্যাড্রেসে আমি পাঠিয়ে দেবো। তার সাথে আমি লিঙ্কটাও পাঠিয়ে দেবো ভিডিও ফাইলের, যদি তোমাদের আরো কিছু বোঝার জানার থাকে, ওখানে আরো ডিটেলিং এ করা আছে, যদি লাগে তাহলে ওখানে তোমাদের এখানে পাঠিয়ে দেবো। এবার আমি তোমাদের অ্যাটেন্ডেন্সটা নিয়ে নিচ্ছি এখানে, আমি ছবি করে। সকলে আছে কি? আর ইউ অল হিয়ার?
Yes, sir.
যারা আসেনি, যারা আসতে পারেনি, তাদের বলবে কি আমার এই যে ভিডিও লিঙ্কটা পাঠাচ্ছি, এই লিঙ্কটা দেখে তারা যেন রিপোর্ট সাবমিট করে দিতে পারে, কারণ ভিডিও লিঙ্কে ক্লিয়ারলি সব বলা আছে, যদি যে দে ক্যান প্লে ইট, এবং ওরা সেটা করতে পারে আর কি। আমি ওদের আমি অ্যালাউ করে দিচ্ছি, কারণ এখন যা পরিস্থিতি, হয়তো নেটওয়ার্ক প্রবলেম কারো থাকতেই পারে, সেটা তো আমি এখান থেকে কিছু করতে পারবো না, নেটওয়ার্কের ব্যাপার আছে। তো তার জন্য আবার একই জিনিস না করে আমি এখানে করছি আর কি। আমি এখানে অ্যাটেন্ডেন্সটা তোমাদের নিয়ে নিচ্ছি হোয়াটসঅ্যাপে, আমার হোয়াটসঅ্যাপ আমি পরে কারেক্ট করে নেবো এটা। অনির্বাণ রায়, অঙ্কেশ কুমার, অঙ্কিত, অভিষেক, অর্ক চট্টোপাধ্যায়, আরয়ন কুমার, আশিস কুমার, এদেরটা নেওয়া হয়ে গেল। তারপরে হচ্ছে
Sir, sir, how can we reach to the stage of sleeping practically? Means how we will get to know that sleeping ho gaya?
Sleeping practically, again I can discuss here. From this diagram, you see that जो इधर जो shaft है ना, connected shaft between the synchronous generator and motor, then there will be a disc, just गोल चक्ति, जिसका जो shading होगा, one black, one bright, okay, and that number of shading is decided by the number of poles. Got my point?
Yes, sir.
Okay. Now, when the tube light is connected us, okay. So if the tube light, you know that in a tube light we cannot see the 0 point. Can you see the tube light in a 0 point? Because tube light is carrying AC current. So there should have some zero glow also. That means dark point. But we
Yes, sir.
cannot see for our persistence. Okay.
Hmm.
Okay. So now, if this disc is rotated with the frequency of the tube light, then you will see that that dark point of the tube light and the shaded black shaded portion will be same coincidence, okay, appearing onto the screen. Got my point?
Yes, sir.
Then you will see that this is as a standstill condition. It is not rotating. When it is under the tube light, you will see there is a magical thing. So you will see that this is not rotating. But when it is sleeping, that means the overloading condition. Suppose it is a overloading condition. So what happens into the power system if it is overloaded? Frequency falls or frequency goes high from the 50 Hz?
So it should fall.
Fall. Okay. So in that case, when the frequency fall, that means then it is going to be so frequency is when it is the less than 40 Hz, you will see that it is going to out of step. Okay, up to 48 Hz, it will not be out of step, but beyond that it will be out of step. Then you will see that this disc is not as match with the supply frequency. Okay, then you will see that it is sleeping. Got my point?
Achha. Yes, sir.
Okay.
Sir,
So this
sir, at
is
that condition, what will be the delta then?
data, that the condition you
Delta,
will see
sir.
that
Sir, what will be the
delta,
load angle? Yes.
no, delta now destabilized. Suppose delta was 45 degree, more than 45 degree, okay. Then it will be, suppose maximum delta can have 90 degree, okay, got my point?
Yes, sir. Yes.
Okay, rotor and stator pole maximum delta can have the 90 degree, peak value. Now at the beyond the 90 degree or beyond some less than 90 degree, it will go out of step. What is the meaning of the out of step? Out of step means there are suppose four poles, stator four poles, north, south. Rotor also four poles, north, south. Now at synchronized condition, all the south pole of the stator will be north pole of the rotor. Got my point? But they will not be in the same alignment. Some delta angle alignment will be there. Got my point? Hello? Can you visualize what I am telling?
Yes, sir.
Yes, sir. Now you are increasing the delta. Then once upon a time, the south pole of the rotor will not be under the north pole of that stator, what was earlier. Now it will shift to the next pole. That means south pole will go the next rotor south pole, and thus it will sleep. Okay, this is called the sleeping condition and out of step. And this is will happen when we increase the loading, because synchronous reluctance motor cannot do that much of loading. But what my point? So that's why there will be a sleeping condition.
Yes, sir.
So now we have Deepan Burman, Faizan Ahmed, Jayanta Moi, Pawan Kumar Barnwal, Prabhuddha Mishra, Prabhu Boydho. Now next question I take. Priyanshu Ranjan. Now Priyanshu Ranjan, Rahul Talukdar, Rohit Kundu, Rupui Tudu, Saptoshi Mandal, Shinjan Patro, and Soham Chattopadhyay. And finally, Soham Chattopadhyay, Somodip Basak, Shobhik Mandal, Spandan Sen Chaudhuri, Shubhadeep Bhattacharya, Shubhamay বিশ্বাস, Subhajit Dey. And finally, we are taking সো শুভময় বিশ্বাস, শুভজিৎ দে, সুগত বিশ্বাস, সুমন্ত পাঠক, যশ সিং. So that's all. I have taken the attendance also. So now I will send you some. হ্যাঁ জয়ন্তময়, হ্যাঁ হয়ে গেছে, সকলকে আমি নিয়ে নিয়েছি। হ্যাঁ এবার হচ্ছে কি তোমাদের ডেটাটা আমি পাঠিয়ে দেবো, আর ওই ভিডিওটাও পাঠিয়ে দেবো যেটা রান করলো না। এটা আর্লিয়ার ভিডিও আছে, আগের বছর নিয়েছিলাম ক্লাসটা। আগের বছর তো 100 জন একসাথে নিতে হয়েছিল, বা সেকশন ওয়াইজ আলাদা আলাদা করা আছে, যার ফলে ওখানে অনেকের নাম ধাম থাকবে। তোমরা সেগুলো নিয়ে বেশি করবে না, তোমাদের পাঠটুকু যেটুকু দেখার দেখে নেবে। কারণ যারা আসেনি তাদের আমি বলছি ভিডিওটা দেখে দে ক্যান সাবমিট দি রিপোর্ট। ওকে, তো আমি কি লিভ করবো?
স্যার
হ্যাঁ
হ্যাঁ বল।